Hello everyone and welcome back to Introduction to Number Theory. In this video we present a very important and very convenient notion in the theory of quadratic remainders, the Legendre symbol. By definition, the Legendre symbol, a modulo p, is either 0 or 1 or minus 1, where we say that it's equal to 0 if a is divisible by p, and we say that Legendre symbol a modulo p is equal to 1 if a is a quadratic remainder, and we say that Legendre symbol a modulo p is equal to minus 1 if a is not a quadratic remainder. Of course, p is a prime number here. In most of the cases we will use that p is greater than 2, which will imply that p is odd. Let's now see some easy, obvious, but yet useful properties of the Legendre symbol. For instance, if we take a primitive root modulo p, and we know that if p is a prime number, then this primitive root exists, say g, let g be the primitive root, and a be equal to g to the power k, well, maybe not equal as an integer, but congruent modulo p. In this case, Legendre symbol a modulo p is simply equal to minus 1 to the power k. Well, it looks as a formula, but actually it states that if k is even, then a is of course quadratic remainder, and if k is odd, then a is not a quadratic remainder. Another very obvious property of the Legendre symbol, if b and c are congruent modulo p, then of course Legendre symbol b modulo p is the same as Legendre symbol c modulo p. This property here, we put this property on the slide because we will often use Legendre symbol for different integers, and we need to understand that we can replace any integer by the integer with the same remainder modulo p. And finally, Legendre symbol is multiplicative, but not multiplicative in the common sense of number theory. For any b and c, for any integer b and c, the Legendre symbol of bc modulo p is equal to the product of Legendre symbols of b modulo p and c modulo p. If any of the integers b or c is divisible by p, then obviously both sides are equal to 0. And if both b and c are not divisible by p, then this property of Legendre symbol follows from, say, Euler's criterion. We can state that Legendre symbol b modulo p is congruent to b raised to the power p minus 1 over 2, because we know that both sides are simultaneously equal to 0, because we know that both sides are simultaneously equal to 1 or minus 1. And the same holds for c, and the same holds for b multiplied by c. And obviously if we take the right hand side of these congruences, the multiplicativity holds. So it also holds for the Legendre symbol. So these are the most obvious properties maybe of Legendre symbol, and in the next video we will study some less obvious property, some of which are really difficult to prove. However, we will use them to determine whether a certain integer is or is not a quadratic remainder modulo prime number.